continuing where we left off on example 10, solving triangle ABC, what we decided is that we have to find angle C first because it is possibly obtuse since it's across from the biggest side. So 12 squared equals 8 squared plus 6 squared minus 2 times 8 times 6 times the cosine of C. We had to get the cosine of C by itself, so we solved for it and take the inverse in order to find the actual angle measurement. So when we do, C is approximately equal to 117.3 degrees. Now that's a rounded answer, and for our further calculations we don't want a rounded answer because everything based on it's going to have some rounding errors. So whatever you get in your calculator, store that as C. Okay, so now let's find another one of the angle measurements. Either A or B, makes no difference. Let's say we're going to pick angle A. It's directly opposite this side 6. So if you notice, we don't have to use the law of cosines anymore. We can switch to the law of sines, and that's convenient because it's quicker and faster to solve. We're looking for an angle, so it goes on top. Sine A over 6 equals sine of. Now instead of writing that 117, I'm going to write sine C over 12. Just multiply the 6 up there. So sine of A equals 6 times the sine of C all over 12. And then I have to take the inverse in order to solve it. A equals inverse sine 6 times the sine of C all over 12. When I punch that into the calculator, I get about 26.4 degrees. So now the question is, how do I find B? Do I have to use the law of sines or cosines? No, I don't. This angle plus this angle plus B should all add up to 180 degrees. So add these two, subtract it from 180, and I get approximately 36.3 degrees for B. So here's a pro tip then. Oh yes, let's notice that on this previous exercise that this was side, 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 which of course is a congruent shortcut. It makes one and only one triangle. We can use the law of cosines in order to find one of the missing angle measurements. Okay, so that's another one of the shortcuts that works with the law of cosines. Here's your pro tip. If you're going to use the law of cosines to find a missing angle measurement, it's a good idea to find the angle that's opposite the largest side because that's the one that could possibly be obtuse. So you want to find, in this case, this angle C first. It's across from the 12, which is the biggest side. After you find that one, then pick one of the other angle measurements, like angle A. We don't, oh man, I went backwards. You don't have to use the law of cosines on that one anymore. Now you can use the law of sines to find that one. Once you have these two angles, just use the fact that all three of them have to add up to 180 degrees in order to find the third